Hello everyone, I'm Sri Chintala, Product Manager at Snowflake focused on extensible data pipelines. This tutorial is a hands-on introduction to Snowflake's external functions feature and will show you how to set up and trigger basic Python code running inside an AWS Lambda. Let's start with the basics. What is an external function? In the simplest form, an external function allows you to call code that executes outside of Snowflake. The executed code is known as a remote service. You can write and call your own remote services or call remote services written by third parties. These remote services can be written using any HTTP server stack, including cloud serverless compute services such as AWS Lambda. External functions opens up the possibility to use any programming language of your choice, including Python, C#, C++, Go, and many others. Some example uses of external functions include calling out to third-party services for geocoding, text analysis, or tokenization, accessing machine learning models you have created and hosted, creating complex custom code or business logic, and so forth. For a remote service to be called by the Snowflake external function feature, the remote service must expose an HTTPS endpoint, accept JSON inputs and return JSON outputs. The function must be callable from a proxy service, and finally, it should be a scalar function. Currently, external functions only support a scalar contract, meaning the remote service must return a single value for each input row. So, how do external functions work? Snowflake does not call a remote service directly. Instead, Snowflake calls the remote service through a cloud provider's native HTTPS proxy service, for example, the API gateway on AWS. The main steps to call an external function are: first, a user's client program passes Snowflake a SQL statement that calls an external function. As part of the query execution, Snowflake reads the external function definition, which contains the URL of the proxy service and the name of the API integration that contains authentication information for that proxy service. Snowflake then reads information from the API integration and composes an HTTP POST request that contains the HTTP header information, the data to be processed, the proxy service resource to use, where the resource contains information about the remote service, such as the location of that service, and finally, the authentication information for that proxy service resource. The POST request is then sent to the proxy service. The proxy service receives the POST and then processes and forwards the request to the actual remote service. You can loosely think of the proxy service and resource as a relay function that calls the remote service. The remote service processes the data and returns the result, which it passes back through the chain to the original SQL statement. Now, let's jump into an example and see how we can trigger an AWS Lambda function using external functions. This tutorial follows instructions from the example featured in the Snowflake docs and shows you in more detail on how you can trigger Python code running on an AWS Lambda. To complete this example, you will need to have an AWS account where you have the necessary rights to create an AWS IAM roles, API gateway endpoints, and Lambda functions. You will also need a Snowflake account with the account admin privileges or a role which has create integration rights. In this tutorial, I'll be following the below sequence of steps which will take you from creating a remote service, in this case an AWS Lambda, to finally calling the external function from Snowflake. Before we get started, I highly recommend that you use the template provided in the Snowflake docs to record the information in some steps which will be used in later steps. So let's jump right in and get started. First, we want to create a remote service which is a Lambda function on AWS. Before we create a Lambda function, we will need to obtain our AWS platform ID. To find the AWS platform account ID, let's start off by signing into the AWS console. Go to aws.amazon.com and sign in to the console. Once signed in, click on the Support option at the top right corner and select Support Center. This will then take you to a new page where you can find the account platform ID listed as the account number. Copy this ID and paste it into the template. Now that we have the platform ID, let's move on to creating a basic Lambda function. To create an AWS Lambda, let's go back to the AWS console. Once back in the main console, search for Lambda. Then click on the Create Function option. Select the default option to author the function from scratch and give your Lambda a name. Pick Python 3.8 as your runtime and then select the default execution role. This will create a new role with basic Lambda permissions. Then click on Create Function. Once created, you should be greeted with the following view where you can write the code for your Lambda function. Before we proceed, let's record the name of the Lambda function in the template provided. For this particular example, we will use the sample code provided in the Snowflake docs. Let's copy and paste the sample Python code provided in step 1 of the docs into our Lambda body. This sample code will simply echo the input provided. You can consider this as a hello world type of example which can be modified later on. Let's deploy the updated Lambda function and test the function using the test data provided in the docs. Let's create a new test event and replace the default data with the test data. If the preceding worked correctly, you should see the following output on your screen. You now have an AWS Lambda function that you can use as the remote service for your external function. Let's move on to the next step of creating an IAM role which is going to be used by Snowflake. From the AWS console, search for and open up the IAM console. Then select roles from the right panel and press Create Role. You should be greeted with a new view where you can define which kind of role you want to create. Let's create a role which has another AWS account as a trusted entity. In the box for account ID, give the same account ID which was recorded earlier in our instructions. For this example, we can skip attaching any permissions or tags. Name the new role as Snowflake role and record the role as the new IAM role name in our template. Select Create Role. Once created, record the role ARN as the Cloud Platform IAM role ARN in our template. We move on to step 3 of creating a proxy service on AWS API Gateway. In this step, we will create an API Gateway endpoint for Snowflake to use to contact the Lambda service which we created earlier. To create this, go back to the AWS console and choose API Gateway Service. Click on Create API. Then find REST API and click on its Build button. Select the new API option. Let's call this new API Snowflake AWS API. Then select Regional as the endpoint type and click Create. From the Actions drop-down, select Create Resource. Call the resource Snowflake Proxy and record the resource name under Proxy Server Resource Name in our template. Next, select Create Method. From the menu, choose Post and then select the gray check mark to create. Choose Lambda function as the integration type and select Use Lambda Proxy Integration option. In the Lambda function field, enter the name of the Lambda function that you recorded earlier and click Save. From the Actions dropdown, select the Deploy API action. Select New Stage and name the stage as Test, and then click Deploy. Once deployed, expand the newly created stage and click on Post. Then record the invoke URL for the post request. Put this in the resource invocation URL field of the template. Now we're done creating the API gateway. Next step is to secure the API gateway such that only your Snowflake account can access it. We now move on to step 4 of securing the AWS API Gateway proxy. In the API Gateway console, go to your API method and choose Method Request. Inside the method request, click on Edit symbol next to the authorization field and choose AWS IAM. Then click the checkmark to save. Click on Method Execution to go back and record the method request on to the template to be used later on. Once done, go to Resource Policy from the right panel and set the resource policy for the API gateway to specify who is authorized to invoke the gateway endpoint. Here, I copy the policy from the example provided in the Snowflake docs. Replace the 12-digit number with the Cloud Platform account ID we had recorded earlier. Next, replace the external function role with the role name of the Cloud Platform role we created, which we recorded as the new IAM role name in our template. In the resource field, replace the resource with the method request on recorded earlier. Save the policy once done and redeploy the API by clicking on the API name, Action, Deploy API. Select the stage we created earlier and click Deploy. We now move on to step 5 of creating an API integration in Snowflake. The next few steps will happen on the Snowflake console, so open that up as a user who has either account admin privileges or a role with the create integration rights. Do not close your AWS console as you might have to return to it later. Type the create API integration command as shown on the screen. Alternately, you can copy this from the Snowflake docs. Replace the Cloud Platform role on with the Cloud Platform IAM role on we recorded earlier. Next, replace the API allowed prefixes field with the resource invocation URL we recorded earlier. Execute the create API integration command. Next, type the describe integration command as shown. Look for the properties named API AWS IAM user ARN and API AWS external ID and record them for later use. We now move on to step 6 of setting up a trust relationship between Snowflake and the IAM role. Next few steps will be done in the AWS console using the values obtained from Snowflake. Do not close your Snowflake console as you must return to it later. Go back to the AWS console and select the IAM role you have previously created. Select the Trust Relationships tab and click Edit Trust Relationship. This should open the policy document into which you can add authentication information. In the policy document, Find the AWS field and replace the value with the API AWS IAM user ARN that we've saved earlier. Find the condition field. Initially, this should contain only curly braces. Type the following between the curly braces. Replace the XXX with the value of the API AWS external ID that you've recorded earlier. When done, click on the Update policy. Next, we go back to the Snowflake console for creating an external function in Snowflake. Type the create external function command as shown on the screen, or alternately, you can copy and paste it from the Snowflake docs. Replace the API integration name with the name of the API integration that you've created earlier. Replace the invocation URL value with the resource invocation URL we've recorded in our template. This example passes two arguments, an integer and a varchar, because those are the arguments that our remote service expects. After this tutorial, when you create your own remote service, you will pass appropriate arguments for your particular function. Let's execute the create external function command. We finally reached the last step of calling our external function. Let's execute the function and pass in the necessary arguments. We can now finally see that the connection is working. The output should be as shown, where it simply echoes back the inputs passed. Congrats! You've just created your first external function. If required, you can grant usage privileges on the external function to one or more roles so that those roles can then call the external function you've just created. If by chance you ran into any errors during execution, check the troubleshooting page at Snowflake for possible solutions. While this is a basic example, hopefully this gave you an idea of how to set up an external function using Snowflake. Hope you found the tutorial useful, and thank you for watching.